Hi everyone. Thanks for coming to my talk about a new phenotyping app called GridScore. My name is Sebastian and I'll take you through this presentation. The importance of data collection is often wrongly underestimated. It's one of the first steps in many projects, and the data collected is used in data analysis and for the setup of follow-on trials. Ultimately, all of these are usually neatly wrapped up in the publication. If errors happen during the data collection, though, all subsequent steps are affected and may have to be repeated, which means a massive setback for the whole project. Manual data collection has a long history. Back in the day, and probably even still today, people used to collect data by just noting things down on paper. In many cases, this will be based on a printed field plan. The issue with this approach is that it's very prone to errors like number swaps and typos. And while it may be fast to record data this way, it requires an additional digitization step later on when you type your data into a PC, at which point you will probably be cursing your bad handwriting. There's a real-life example down here of an old scoring sheet, and it should be pretty obvious that this is not an ideal way to collect data. The natural next step forward was to use either laptops or tablets and type the data directly into Excel, because in most cases that would be where the data ends up anyway. While it is a significant improvement due to the removal of the digitization step, Excel, even on a tablet, does not have the easiest ways of entering data. Devices can also be quite heavy and are generally not fit for purpose. The latest development is the use of specifically designed phenotyping apps tailored towards touchscreens. Examples are Germanet Scan, KD Smart, and Fieldbook. Some of these focus on barcode-based entry, others on a more guided approach, taking the user through the field step by step. I talked to a number of people about the ways in which they collect their data and how this could be improved and what their requirements would be. I also went out into the fields with them to observe them and talk things through. All of this led to this short list of requirements for an ideal app that most people seem to agree on. The two most important requirements were that the app should kind of represent the field plan for easier navigation and identification of individuals, and that the data entry should be easy and fast. The app should work in different scenarios like fields, polytunnels, and glasshouses, and it should work across crops. Support for barcode-based data entry would be good, because lots of the individuals already have barcode labels on their pods, branches, or stakes next to the plots. Automatic image tagging was also a requirement, along with georeferencing, both during the data collection for better orientation, but also for associating the data points with their geographic location. The app should work offline and not require an internet connection, and ideally it should run on any reasonably modern device. So as you can see, people had only a few very reasonable demands. Taking all these requirements into consideration and also learning from existing phenotyping apps, we developed a new tool called GridScore. For the next part of the presentation, I will switch between the PowerPoint slides and a live demonstration of GridScore. I will run through the following steps, starting with the creation of a trial, which is obviously an essential step, and it will be the first thing most people will do when they use GridScore. I will then show how to collect data using GridScore, followed by a demonstration of some of the visualizations we added. After that, I'll showcase some of the more advanced features, and finally I'll show how to easily share trial configurations and the actual data between devices within just a few seconds. Now, this is the main screen of GridScore when you first visit. You have the options to set up a new trial, load an example trial, or run through an introduction tour. We would start by setting up a new trial. The trial setup screen has some required fields and some optional bits at the end. First, you have to give your trial an ideally unique but definitely descriptive name, so you can always identify your trial easily. Next, assuming a relatively grid-like layout, you define the number of rows and columns in your trial. After that, you have to specify the germplasm or the varieties you are growing in your plots or pods. And these can either be pasted in or loaded from a file. Finally, you need to specify which traits you want to score. In this example, we are scoring 3 date-based traits on tipping, heading, and maturity. followed by a numeric trait, plant height, and finally, just to show a categorical trait, we have the row type. Numeric and categorical traits can have restrictions placed on them, like the minimum, maximum, or the valid categories. In the case of the row type, we have 2 row and 6 row as the categories. Optionally, you can define the corner points of the trial. Doing so will allow GridScore to highlight your current position on the data entry table, as well as on all of the maps that are scattered throughout GridScore. Now that we have created a trial, this is the main data input view. You can see it resembles a field plan with your rows and columns. Each cell represents a plot or a pot. You can easily scroll around the table to find the one you're looking for. Clicking on the cell will open the data input dialog for that individual. Here you have input fields for each of the traits you defined. Depending on the type of the trait, this will be a date selector, a number input, a text input, or a select dropdown. Let's set the on tipping to today and the row type to 6 row. The other traits will be scored at a later date. Moving on through the field, the next plot isn't ready yet, so we're going to skip this one for now. Looking at the third plot, let's say that on tipping actually happened yesterday, so we can set that value as well as the row type. Entered data is represented by these colorful blobs on the grid. These show you which trait has already been scored for each plot or pot, so you can skip them next time you come back. If we now continue this process and come back a few weeks later, the grid may look like this. At this stage, some plants might already be at the next stage. So let's walk through again, starting at the first plot. Now the heading event has taken place, so let's set the date here as well. The next plot, again, is slightly late, and we need to skip this one for now. The third plot isn't quite there yet, but we can tell that it will reach heading tomorrow, so we can predate this one. But let's also add a comment to check again tomorrow to make sure that it actually happened. You can also invert the view to highlight plots that still need to be scored. As you collect data, this view will become more colorful, which is a nice little motivation. After a while, it'll look like this, and most of the data has been recorded. Now let's have a look at some of the visualizations. GridScore can show your data in a temporal context. This chart shows time on the x-axis and the completion percentage per trait on the y-axis. In addition to showing your progress for each trait, this chart can be used to see if there's any temporal correlation between traits. In this example, we can see that on-tipping, heading, and maturity follow roughly the same curve. On-tipping and heading are offset by around a week, while maturity sets in around 6 weeks later. The second type of visualization is the field heat map. By selecting a trait, you can look at the distribution of values across the trial. This is particularly useful to identify clusters of similar values, which could, for example, indicate different soil properties, as well as edge effects. I'll come back to the presentation now because the remaining features are difficult to show live. I mentioned initially that barcode support was one of the requirements for this app. Existing barcodes on the pots or stakes next to the plots can be used for faster identification of the individual. So if you approach a plot or a pot and there's a barcode on it, like the one we see up here, if you scan it, that will open the data input dialog in GridScore. Barcodes can also be used for the actual data entry by creating barcode scoring sheets where each individual barcode represents a unique trait value. One thing that we have done is we have created a measuring stick to measure the plant height, where we've got a unique barcode at each ½ centimeter. So you just scan the barcode at the appropriate height and the app will know how tall the plant is. If the corner points of the field have been defined, we can use that information along with the GPS coordinates of the mobile device to highlight your position within the trial. So as you move through the field, the closest plot in the data entry view is highlighted. This should make it easier to identify the plot you're looking for. Often you want to take a photo of something you see while you're out phenotyping, so something that looks interesting or out of place. Or you just want to create a catalog of images for all your plants. Previously, that would involve using a digital camera or the phone and then take the photos, and then at a later date renaming the files to reflect the individual you've taken the photo of. That's a very tedious job and can often lead to mistakes. GridScore can help with this by automatically tagging images you take with the current timestamp, the identifier of the individual, and also your GPS location, removing the need to manually rename dozens of images. One feature we've used before that has been very popular is automatic voice feedback for data entered through GridScore. This means that the app will speak whatever you enter as data, so you can be sure it is correct. If you've got headphones in, you'll clearly be able to hear what data you just entered, and you'll be able to fix any potential mistakes right away. Additionally, we now support voice recognition for notes. So if you quickly want to add a comment to a plot, press the record button and start talking. GridScore will convert this into text and associate it with the plot. The last feature I want to show may be one of the most useful ones. It allows you to share trial setups or even all the data you recorded between devices by simply scanning a QR code. Now, this means that you can set up your trial on your laptop while having a nice cup of tea, then sharing it to your phone by scanning a QR code. Then you go out into the field or the polytunnel, you collect the data using the phone, and when you get back to your desk, you can share the data back to the laptop the same way. This concludes my talk about GridScore. I hope I created some interest and some of you are going to check it out. It's completely free and open source, and it's available at this URL, or you can just scan this QR code here. After you've tried it yourself, please get in touch if you have any questions or feedback. As a quick summary, accurate data collection is really important because your research depends on it. I've presented GridScore, which is a new phenotyping app with lots of interesting and helpful features. It's designed to make the data collection process easy, fast, and maybe even fun. Give it a go and try it yourself. We hope you find it useful, and we're happy to help you get set up. I'd really like to acknowledge all the open source and free tools and services we have used to create GridScore, as well as all the other people involved. Biggest thanks to Miriam Schreiber, who triggered the idea for GridScore, and who also tested GridScore in Bali. I'd also like to thank Dorota Jarrett and Gaynor McKenzie, who are going to trial the app this year on blackcurrants and potatoes. Additionally, thanks to Joanne Russell, Luke Ramsey, and Paul Shaw for their valuable input during the creation of GridScore, and obviously also to the funding bodies.